I'd forgotten about that last paper. It's something I wrote in graduate school, and the person who was most happy to hear that news was my mother, because I'm the oldest of 4 sons. So thanks very much for the opportunity to come speak here today. I'm going to present a kind of overview of a research project that I have that I launched in collaboration with Eric Lindquist and Robert Usling as much as 6 years ago. And I should say I come from a tradition where it's quite common to ask, to sort of interrupt the speaker, so I'm very happy to answer questions throughout, and if not, I'll hopefully leave some time toward the end of a question, but either way is fine with me. So what I want to do today is I want to really give you an overview of the findings that we've come to in a series of analyses of a large sample of Swedish lottery players. And what's nice about these samples is that we have information about lottery prices, most of them quite large, that induce substantial changes in wealth, large also from a life cycle point of view. So, loosely speaking, what we're going to do is we're going to compare people who won large prices, and by large I mean something in the range at least $100,000 and up to $800,000, to matched controls from the same lottery. So it comes quite close to mimicking the sort of gold standard of a randomized controlled trial that just randomly assigns substantial amounts of money to people. And then, because these are Swedish data, we can match players both to government records with detailed information about post-lottery outcomes, so we can sort of get clean causal estimates of the impact of lottery wealth on a host of outcomes. And what I will be talking about today are really ongoing work on subjective well-being and health behavior. So these are not things that are well measured in the registers, but we administered a survey to the players last fall, and in determining what to measure on the survey, we focused naturally on things that aren't very well captured by the administrative variables. Okay, so just to set the stage, so 4 of the outcomes that I'll be looking at today, I'll provide much more detailed definitions of these things later. Our financial life satisfaction, something we call happiness, overall life satisfaction and mental health. When you look in the cross-section, what you see is that there's a more or less positive relationship between income and sort of the average of these 4 variables. And it's well known from earlier work that this cross-sectional gradient is roughly linear in the log of household income. So what that means is that the association between an extra dollar at low levels of income and each of these outcomes is a lot higher than the association at higher levels of income. So that's usually why people look at the these relationship in a regression framework where we do some take some concave transformation of income, typically the log. Now, when you look at these relationships, a number of questions comes to mind, and the obvious one is what accounts for them. And by the end of today's talk, I certainly won't pretend to have answered that question, but hopefully the evidence I'll be showing you is relevant for at least discriminating between some of the hypotheses about what could explain these patterns. And so in particular, the 3 obvious things that come to mind is that to some extent these measures of psychological well-being could impact your ability to make money. To some extent, it may be that higher income increases your ability, or makes you happier or more satisfied with your finances, or improves mental health. And to some extent, it may be that there are unobserved factors that make people both increase both people's psychological well-being and increase their incomes. So what we're going to do is we're going to use these rich administrative data. Using this rich administrative data, we're going to identify a survey population composed of lottery players. In doing so, we'll oversample very large prize winners. And then for each of the lotteries that we have data on, we're going to construct cells of players within which we know that the amount won was randomly assigned. I'll explain that in greater detail. And then we're going to control for these cell identifiers or group identifiers to ensure that we really have an experimental comparison, meaning that all the identifying variation is based on people who participated in the same lottery, ex ante had the same chance of winning the lottery, but one of them happened to win a larger sum of money than the others. And that's the sense in which what we do is going to mimic an RCT quite closely. Okay, so let me talk about the 3 lotteries that we're going to base our study on. The first is we're going to call Combi. So Combi is actually a monthly subscription lottery run by the Swedish Social Democratic Party. And we have data on a panel of about 500,000 players who participated between 1998 and 2001. So the data are in panel format, and then each month, so there's a lottery draw in each month. And for each month, we have information about the number of tickets played and whether or not each individual won a prize. So what we're going to do here is basically we're going to take each large prize winner, and by large prize here I mean more than $150,000. And then we're going to take each large prize winner a given month, and we're going to match him or her to 4 what we call controls, and these are just people who participated in the same lottery in the same month of win with the identical lottery balance as a winner, but they didn't win. So that should give us an experimental comparison. And here's a sort of simplified view of how the description of the data and how that works. So we have one column with something like a social security number that's unique. We have information about what the person won or not. We have information about the number of tickets in the month of win. So here's, in this hypothetical row, we have a person whose social security number is 13. They won in the month of December 38, and they had 3 tickets, and therefore they would be matched to other players with 3 tickets and assigned to the same cell. And in practice, what we do to kind of improve precision is we choose controls who are matched on sex and age whenever that's possible, which is almost always because the population of lottery players is so large. Yeah.
And because you have registry data, can you match on pre-lottery income or education level?
Yeah, we could do those things in principle. In practice, we don't, because we found that the two variables that seem to buy us the most leverage here are sex and age. And once you go beyond that, it starts getting a little bit iffy because you can't find perfect controls. But probably we could have done that as well. And we do have pre-lottery, a lot of pre-lottery variables. Okay, so our second 2 lotteries come from something called TV Triss. So Triss is a scratch-off lottery program run by the Swedish gambling monopoly called Svenska Spel. And since 1994, there are 2 major types of prizes that you can win, and both of them involve appearing on a morning TV show. And at the show, you draw a prize from a fixed stack of lottery tickets in 2 ways. Okay, there are 2 types of prizes you can win. There's one combination of symbols that you can scratch that makes you eligible to participate in something that we're going to call Triss lump sum, for reasons that should be obvious. Triss lump sum winners, they just draw a single prize from a stack, from a distribution whose prices range from about $7,000 to $700,000. The details vary a little bit over time, but not much. The reason we call it lump sum should be obvious. They draw a single prize, and then it's paid out to them within a matter of weeks. The second type of prize we're going to call Triss monthly. Conceptually, it's very similar, except that you now draw 2 tickets. The first is a monthly income supplement. It's going to range from $1,500 to $7,000. And the second is a duration, which is going to range from 10 to 25 years. So for comparability with the lump sum prize, we convert these to a net present value. Let me say also that here, and in all that follows, the dollar amounts that I'm going to give you are net of taxes. Okay? So then so what we do here is that we just say that the 2 players are in the same cell if they won the same type of prize, that is Triss lump sum or Triss monthly, under the same price plan and in the same year. So a price plan is really just a regulatory document that determines the exact distribution from which you draw your prices, right? So here the identification strategy is not to compare winners to non-winners, but to compare winners who participated in the same lottery, and some are going to win very large amounts, and some are going to win more modest amounts, and the players who win more modest amounts are going to be our controls. Okay. So before I turn to the results, let me say something about some obvious and I think quite important objections that routinely come up about this sort of work. In all cases, we try to think through them in the design stage of the study and do what we could, subject to some obvious constraints, to design the research in a way that would allow us to explore whether our results, to what extent our results are sensitive to these things, and sometimes I think we were more successful than others. So a first very common objection is that lottery players are different. I'm going to show you in a couple of slides, how the lottery players in our sample compare to the general population. So that's one thing we're going to do to try to sort of look at this. The other thing is we're going to use data from multiple lotteries. The original administrative studies we did, which looked at outcomes in the registers, were were actually based on 4 separate lotteries. One of those we aren't going to be included in today's analysis of survey-based outcomes because the prizes were all awarded in the 80s, and so we sort of made a decision not to include that population. But even today's talk will be based on players from 3 separate lotteries. I'll show you how representative they are of the Swedish population. But of course, there's an issue that we are limited in how much we can say about the extent to which the results I'm about to show you might generalize to other non-Nordic countries, perhaps. And the second sort of general objection or general concern about external validity is that lottery wealth is different. Here I have a couple of things to say. The first is that in my experience, very often this concern is based on a presumption that is widely known that lottery winners don't squander their wealth or engage in frivolous spending sprees after they win. And if you look at the, and I think to some extent this is this presumption is based on regular media accounts about lottery winners who ruin their lives. I actually think the underlying psychology here is that those of us who are not millionaires love to hear stories about millionaires who are miserable. But if you actually look in the data, millionaires are happier than less wealthy people. And so really the correct comparison here ought to be to take, and there's no question that some people who win large amounts of money go on to squander their lives. But I think the relevant kind of factual is how many of them would squander their lives even without the lottery wealth. And at least in the data, as I'll show you, I don't think there are very many signs of hints of the lottery wealth that makes you miserable kind of story. I'll provide some illustrations of this. The other obvious objection is that maybe the mode of payment really matters. Most lottery prices, and I should say on this point also, this is entirely consistent with what sociologists who have looked at this qualitatively have concluded. Here in the US, there's a sociologist called Roy Kaplan who's written at least one book on lottery players, and one paper also which sets out to kind of dispel what he perceives to be the mythology of lottery players and all these ideas that they're not representative and that they squander their wealth and that within 3 months of winning the money it's all gone. Which is not to say that those thoughts have some basis in reality, but it's very hard, at least what I can say is it's very hard to detect evidence of that sort of those patterns of behavior in our data. Okay, so back to heterogeneity by mode of payment. An obvious concern here is that most lottery prizes are paid in lump sum. Maybe that means lump sum wealth has different effects than wealth changes that are realized through sort of changes to monthly payments or something like that. And we're going to try to address that by including at least one lottery in which the prizes are paid in the form of monthly income supplements. A third, which I don't think we can fully address, is that lottery wealth is unearned. So to the extent that you think that the unearned wealth has different effects than earned types of wealth, maybe the way to think about our estimates is that they tell you more about things like the likely consequences of guaranteed basic income programs that are currently being discussed, and maybe we should be more cautious about extrapolating to other types of wealth. And the last thing I'll point out is that overwhelmingly all of our players who were surveyed at least 5 years after the lottery event, and in some cases up to as much as over 20 years. So what that means is that this long-run qualifier is very important. It's entirely possible, in fact, I think it's true, that immediately after winning you experience these feelings of euphoria. And really, what this study is going to be about is whether those feelings completely vanish over the time horizon of a few years or so, or whether there are some persistent effects that we're able to detect in the data. Okay. So first, I promised to show you something about whether lottery players are different. Now, I should say one caveat here is that lottery players are different in one important sense in our data, and that is that they're older than the population as a whole. So in our data, they're about 10 years older than a randomly selected Swedish adult. So all of these numbers are conditional on reweighting a representative Swedish sample to match the sex and age distribution of our lottery sample. the sex reweighting doesn't make any difference because our sample is roughly 50% male, 50% female, but the year of birth reweighting does matter. So with that caveat in mind, I think these numbers on the whole don't provide a ton of evidence that I guess it's in the eyes of the beholder. I don't see any dramatic differences here between players and non-players. And just to be clear about what I'm showing here, I'm showing you data for the people who responded to our survey. I'll have more to tell you about how we came up with that population. So the column 4 gives you the pooled sample of survey respondents, and column 5 shows you the same. The column 6 shows you the same information about the from a representative sample. So maybe the one thing that's where we see a meaningful difference is that 92% of our players are Swedish-born, whereas 84% in our representative sample are Swedish-born. But that's really a kind of an artifact of which year you choose to draw the representative sample. We drew it in 2010. So if you'd done the same exercise in 1990, you would have gotten very different numbers because Sweden's had a lot of immigration in the 20 years or so that passed between those 2 points in time. Okay, so now on to this common intuition that lottery players routinely squander their wealth. And what I hope to convince you now in the next couple of slides is that at least in aggregate there's very little evidence of this. So before we turn to the survey outcomes, I just want to show you how people respond in terms of their labor supply and how they respond and sort of how the wealth trajectory post-lottery evolves. Okay, so the point here, so here I'm showing you the effect from a paper of ours that's in press of lottery wealth on labor supply. And a coefficient estimate here of 1 means that if I win $100 in year 0, so year 0 is like normalized to be the year of the lottery event, if I win $100, then my earnings in post-lottery years per year, my annual earnings are going to be about 1% lower. So that is to say, if I have $100 more in the bank, I earn $1 less per year. And as you can see here, at least in the 10 years that follow, it looks like that reaction is pretty persistent, which I think it's interesting. It's not entirely in line with what we expected, but it certainly seems to suggest to me that people upon winning sort of really try to smooth out the sort of consumption gains of the win over a long time horizon. Yes?
Is the 0 centered on the exact date of the lottery, or is that half the coefficient because on average there's
Correct.
6 months of the year in which they won?
Yeah, that's a good point. So Dalton's question is why is the effect not as big in the year in year 0? And the answer is that the average winner wins in August, so they only have 6 months to cut down their labor supply. Or not August, but yeah, the point's the same. Okay, so and the second point here is like what about post-lottery wealth? Okay, so here I'm showing you the effect of winning the lottery on your year-end wealth in the post-lottery years. The important caveat here is that year-end wealth is measured by is based on the government register measures of wealth, which we have data on from 1998 to 2007, I think. And the reason that the Swedes collected these data was that they taxed wealth until they had a wealth tax that was abolished in 2008. So for every citizen, they gathered information about year-end wealth. Now, so what this coefficient means is that if I win $100, then my year-end wealth is going to be about $60 higher in year-end in the year of win. Now, that does not mean that I spend $40 for each $100 won in the year of win. And the reason is that even though the Swedish wealth data are quite high quality, there are a lot of things that they're going to miss. For example, if and sort of the sociological literature seems to suggest that gives us some cues about how people spend their money in ways that wouldn't be detectable here. One thing people spend their money on is on things like home improvements, so that wouldn't show up here. The data aren't that good. To the extent that they're transferring money to their children, that wouldn't show up here. The 60% estimate we're showing you does include spousal wealth, and a good chunk of the wealth does end up being transferred to one's spouse. And there are also other types of wealth that we would just miss here because the data are imperfect. For example, car ownership or investments in durables. Yeah.
So these answers, the clarification.
Yeah.
all these coefficients are relative to before minus 1, or what's the 0 here?
The 0 is the year of win. So the minus...
What is 0 on the y-axis?
0 on the y-axis is, so that would imply that the estimated effect of $100 on your, so this is, you can think of as a falsification test.
Yeah, but
My
relative to what?
Relative to matched controls.
Oh, I
So,
see, sorry,
yeah.
so they're estimated each year separately.
Yes, separately, yeah. And of course the fact that the confidence intervals here overlap 0 is good because we don't think that lottery wealth, the lottery outcome in year 0 should be impacting your lottery wealth at year end before the lottery. Yeah. So on the whole, I think of this as a sort of lower bound on how much of the lottery wealth that's that's spent in year 1. And it's probably not a very informative lower bound. My guess is that the true coefficient here is a lot higher than 0.6. Okay.
That also doesn't take into account the labor supply reduction, right? So they're probably...
Right. Though that reduction is probably pretty modest, but sure, that would go in here. Okay, so the last thing I'll say about the administrative studies before I turn to the survey is that we've looked in quite some detail at how lottery wealth impacts a bunch of health outcomes that are, or sort of proxies for health outcomes that we can measure in the Swedish administrative records. These include sort of mortality, hospitalizations, overall health, and drug consumption in various domains. And the only outcome where we see, I think, reasonably clear evidence of an overall reduction is that the consumption of mental health drugs goes down in the years following the win. The coefficients here in units of $150,000 again. So these effects are quite small. So what do these numbers mean? Well, they mean that if I give you $150,000, according to our estimate, your consumption of mental health drugs, which is the sum of anti-anxiety medications, sleeping pills, and antidepressants, falls by about 30 prescribed daily doses, and that's a fairly small effect. It's about 4 or 5% of a standard deviation, or relative to the mean consumption in the population is about 10%. Okay. Yeah?
So the key predictor in all of these is dollars of wealth gained from the lottery?
Yes, measured in units of 150,000, yeah.
So are there cases like that win a whole bunch of money and get a huge amount of leverage in these models? And have you checked to see if the association is really like linear with dollars?
Yeah. No, so it's a good question. It's a good point. So yeah, we do have one robustness analysis where we do just drop the large prices, and that doesn't do much to this result. In fact, it is kind of surprisingly linear. We have a second one where we just do spline regressions. Again, it looks pretty similar, though it's not clear how much power we have to say something about the marginal effect of wealth at very low levels. And then there's a third exercise that we do. Okay, no, I told you about that already. We drop the large prices. So in fact, that's also one of the robustness analyses that we do in the results that I'll show you today. Because it didn't change anything, I'm not sure I have those numbers in the slides, but I'm happy to share them. Okay, so now on to the survey. So we restricted the survey to 3 of the original 4 lotteries that we included in our administrative studies, or our studies of administrative outcomes, I should say. We obviously oversampled large prize winners, and so we included all winners from the TV TRIS lotteries, and we included all large prize winners from the Combi lottery, and then 4 matched controls for each of these large prize winners. So the sum of prizes awarded to the members of our survey population is about $400 million net of taxes. So that means that even though the original administrative samples were about 500,000 people, up to 2 million, depending on how you define it, and even though we drew a subsample of about 4,000 people, we still retain about 50% of the identifying variation, even though it's a tiny subsample. And the reason is that most of the large lottery prices are still in our data. Yeah.
Could you explain a little bit more about the TV TRIS thing?
Yeah.
For example, do they get to choose whether they do the lump sum pile
Yes.
or the?
They do not get to choose.
Okay.
Mm-hmm.
How do they get selected in the first place to get on TV?
They scratch a ticket, and
I see that. You win to go select.
And if the ticket has like 3 symbols that look like, is it called a clover
It's like a
in English?
jackpot,
Yeah.
yeah.
So you got one combination, one trio of one particular combination of scratched symbols means you get to be in the lump sum lottery, and another one means that you get to be in the monthly
So those
lottery.
players just happen to be a younger group, it's not that the TV was, yeah. okay.
Yes, they happen to be a younger group. It's a younger population, yeah. So the main age restriction, in fact, most of the reason why this number is not closer to 100% is that we limit the survey to people aged in the range 18 to 75 in the year of survey. And a good chunk of our players are actually substantially older than 75. Some of them are in fact deceased. Okay, so here is a by 2017, yeah. So the timing of our survey, we sent out a letter of invitation. We gave them a gift card. The gift card was unconditional. We just gave them $15 and thanked them preemptively for participating. And it was sent out by Statistics Sweden, mostly to sort of boost the credibility of the data collection effort. Then there were 3 reminders sent via mail. 2 of them with surveys, the first one without a survey. Then we did telephone reminders to the TRIS monthly players. The reason we targeted those is that the prices are the largest there, so they contribute the most in terms of power. And then in the last step, we did a telephone follow-up of non-respondents. We sought to reach 500 of them, and basically the telephone follow-up asked them if they were willing to complete an abbreviated version of the survey via telephone. The idea was to just give us a rough sense of the characteristics of the non-respondents. Okay, so I told you this already. Handled by Statistics Sweden. It made no mention of lotteries, the cover letter that accompanied the survey, and that's for obvious reasons. We don't want to color people's responses by reminding them that telling them you're being surveyed because you participated in a lottery. This was actually a little tricky to solve without upsetting IRB, and so the way we handled it was, so IRB insisted that the players be given a chance to learn about how the sample was chosen. So what we did was we put in each cover letter a unique URL with a website that contained complete information about the selection of the sample, and then unbeknownst to the subject, we could track whether each particular subject actually chose to participate, chose to click on that link and find out that okay, I was chosen because I'm in this lottery population, and fewer than 10 people did. I think the final number was 3 or 4. So in practice, this is not an issue. People are not that interested in knowing why they're being surveyed. We kept the survey relatively brief to encourage participation. We had these reminders and we had the telephone follow-up. So the mail-in response rate was about 67%. Okay, so that's actually pretty respectable by Swedish standards. 10 years ago, it would have been considered a poor outcome, but Swedes are still pretty cooperative when it comes to these things. And then among the 500 randomly chosen non-respondents whom we targeted through the abbreviated survey, we got another 111 responses. So our final response rate is just shy of 70%. Okay. Okay, here are some features of the 3 final of the survey population. So here we're showing you the original survey population and the distribution of prices. So in TRIS lump sum, you can see that a lot of the identifying variation comes from comparing these small price winners to people who won larger sums of money. You can see in the second column that the TRIS monthly prices converted to net present values contribute a lot of identifying variation. So even though there are only 570 individuals in this population, the fact that we have so many large price winners means that in terms of statistical precision, these lotteries are roughly equivalent in terms of contribution. And finally, from Combi, we have about 1,200 players. And here, you do very little harm in thinking about this as an experiment that compares people who won $0 to people who won a prize in the range of $100,000 to $400,000 net of taxes. Survey participation was reasonably uniform across the 3 lotteries, a bit higher in Combi. And our final, what I'm going to call our respondent sample, is a sample of 3,400 individuals, roughly, who participated overwhelmingly by returning the mail-in survey. This number varies a little bit depending on the exact outcome we look at, but because sometimes one of the survey responses is missing, but those differences are not substantively important. Okay, so we uploaded a pre-analysis plan on the Open Science Framework on November 23rd, 2016. That was before we'd accessed any of the individual level data. It was all being collected by Statistics Sweden. And the obvious goal of the plan was to sort of mitigate concerns about undisclosed multiple hypothesis testing or other investigated degrees of freedom that might sort of complicate the interpretation of the results. So we specified a bunch of diagnostic tests that were supposed to convince readers or test or identify an assumption that within these cells the wealth is randomly assigned, the lottery wealth is randomly assigned. We specified the analytical framework we'd use to estimate the treatment effects. We specified a bunch of primary outcomes for each of our studies, and we listed the 3 studies that we were planning to do on these outcomes. I'm going to talk about the results from 2 of them today. So one on psychological well-being, and a second on health behaviors. We specified some robustness tests. One of them being one of them involving dropping the large prices, the issue that came up earlier. We specified some heterogeneity analyses, and we also talked about how we intended to benchmark the causal effects that we ultimately estimated, because we didn't think that the null effects are necessarily the only interesting, or perhaps even the most interesting benchmark for these estimates. So, for example, we specified ex ante that we also wanted to compare our causal estimates to the cross-sectional income correlations that I showed you at the beginning of the talk, and also to previous estimates from the literature, and I'll have more to say about that later. Okay, so the first thing we did then was just run 3 diagnostic tests. They all came out the same way, and so I'm just going to show you very quickly what happened. And I should say here, the intention of this analysis plan, which I think was, we were successful in accomplishing, was to specify all the analyses with sufficient detail that anybody with access to the plan and the data would be able to produce exactly the same, produce a final set of numbers without having to make any additional judgment calls. So we even had things like specified how we would handle outliers and inclusion criteria, these sorts of things. Okay, so the first thing we want to check is, of course, that the lottery wealth itself doesn't predict whether or not you chose to participate in the survey, because that could introduce biases. It would mean that even if our identifying assumptions hold in the population of lottery players, it may fail to hold in the subsample of survey respondents. And so we look at whether lottery wealth predicts whether you returned a survey, and regardless of how you define survey participation, the answer is that we find no evidence of this. The second thing we do is that we check whether the prices assigned within each of these cells or groups are predicted by pre-lottery characteristics, and we use exactly the same set of pre-lottery characteristics that I showed you in the table showing the representativeness of our sample. And the answer is that no covariate individually predicts at the 5% level. A significance threshold of 5% is associated with the price amount 1, nor is it the case that the covariates jointly predict the price 1 once you condition on these group fixed effects. And so that's consistent with what we'd expect under our identifying assumptions. That's pretty reassuring, and we were very nervous before we hit the button here, because it would have complicated things a lot if these analyses hadn't come out the way we were hoping they would. Okay, so now I'm going to show you results from 2 out of the 3 studies that we pre-registered. And the first one, we're going to look at psychological well-being. And so here we pre-registered 4 outcomes. I'm also showing you pairwise correlations between them. And bear in mind this very high correlation between happiness and what we call life satisfaction, because I'll return to it later. So by happiness we just mean, we measured it just using a world value survey question that just asks subjects, all things considered, how happy would you describe yourself as? I think my understanding is that in terms of the jargon of the psychometric literature surrounding the measurement of psychological well-being, this is sort of a mix of an affective and an evaluative measure of well-being, because on the one hand it asks about happiness, feelings of positive affect, but on the other hand it asks you about your all things considered, which is kind of evaluative, gives it an evaluative component. Overall life satisfaction is, again, I think from the World Value Survey, standard question, taking all things together, how satisfied would you say you are with life these days? We measured a bunch of domain-specific measures of life satisfaction, but we only pre-registered 1 as a primary outcome, and for obvious reasons, we chose financial life satisfaction. It seemed a priori it seemed plausible to us that this is the one domain of life satisfaction where we should see the largest changes if somebody wins a lot of wealth. And our last measure of well-being is an index of mental health, or really a screening instrument for mental health called the GHQ, the General Health Questionnaire. Okay. In all analyses that follow, I'm going to show you sort of standardized. I'm going to standardize these to have mean 1 and standard deviation 1, so that's relevant for interpreting the coefficients. In our study of health behavior, we're going to look at, or maybe I should say subjective health and health behavior. We're going to look at a total of 6 outcomes. The first 2 are what we're going to call subjective and objective health. Subjective health is just based on the response to a question, how do you judge your overall state of health overall? It's not a question that's often used in economics, but I think it's an excellent question. As an empirical matter, it's very predictive of of things like mortality. Our second, which I'm going to call objective health, maybe the word objective should have inverted commas around it, is just a weighted average of 35 health conditions that we asked about. And the weights are derived by trying to predict in an independent sample the mortality risk 5 years from now, and then we just take a weighted combination of, we calculate the weights that best predict mortality, and then we take the subject's responses in our sample and we weight them to get in a sort of overall index of what we call objective health. And then we have 4 measures of health behavior that for which at least there were some hypotheses a priori that lottery wealth might change your behavior. We ask about smoking, we measure alcohol consumption, we measure physical activity, and we have a measure of dietary quality. And though I won't show it here, if you sort of plot the cross-sectional gradients that I started with for these 4 outcomes, of these 6 outcomes, they look very similar to what people have reported in the literature before. Greater income is associated with better outcomes in terms of subjective health and objective health. Greater income is also associated with quote-unquote better health behavior, so less smoking and drinking, more physical activity, and better dietary quality. Okay, so let me show you now some of the key results for psychological well-being. So here are the results for the 4 primary outcomes. I'll try to be explicit about anything that's sort of based on a post-hoc analysis. And so what we see here is that we found 2 outcomes where there was a sort of treatment effect that's robustly different from 0, even after the multiple hypothesis correction that we specified in the analysis plan. And one interesting thing is that despite the high correlation between these 2 outcomes, happiness and overall life satisfaction, we can actually rule out homogeneous effects on these 2 things. So remember, they correlated at 0.86. This is not something we anticipated. I think the results should be interpreted with a bit of caution. But for what it's worth, we found that the wealth effect on overall life satisfaction was a lot stronger than the effect on happiness, despite the high pairwise correlation. And maybe that's relevant for interpreting some of the evidence that's out there. For example, there's some evidence by your Princeton colleagues Angus Deaton and Daniel Kahneman that the income gradients with respect to evaluative and affective measures of well-being are different, and one way to interpret this difference is that that's also true if you're interested that the causal effects of wealth on these 2 different types of outcomes are also different. Perhaps unsurprisingly, we see the largest effect on financial health, and the estimated effect on mental health is the smallest. We can rule out effects that are pretty small, and I'll make an explicit comparison to the income gradients in a couple of slides. As I mentioned, we also measured these other domain-specific questions about life satisfaction, and we don't find any clear evidence that any of them change, with a possible exception of spare time, which I think maybe if you combine this result with the fact that we know labor supply goes down, maybe that suggests that some of the effect on overall life satisfaction is mediated by improvements in the domain of spare time. But by far the most important mediator appears to be financial life satisfaction based on these results. We see very little evidence that things like happy satisfaction with your friends or relatives or overall health or society as a whole or anything like that changes. So that's, now then we'll also look at how these things vary in subsamples stratified along 5 different dimensions that we specified ex ante. So the first is year of win. We asked whether the lump sum or monthly effects differ significantly. We asked whether the effects vary by income, by age at win, or by sex. And on the whole, we don't find a ton of evidence of treatment effect heterogeneity here. The one thing that stood out to us was that, if anything, there's a tendency for the effects to be larger among players who won before 2005. 2005 we chose just because that was a median year of win in our samples. We just split them into 2. And that, that's certainly not something I expected. I think we would have predicted that the effects decay with the passage of time, and maybe they do. Maybe this is a chance finding, but I mention it because this is what we found, and I'm not entirely sure what to do with it. Okay. I mentioned at the outset that we were sort of we were not just interested in making the ruling out zero effect. We think there are also other effects that are interesting to non-zero effects are interesting to try to rule out, and one of them is, of course, the cross-sectional income gradients. And so what I'm showing you here is an attempt to make our lottery estimates comparable to the cross-sectional income gradients that I showed you at the beginning of the talk. So how do we do that? Well, what I'm showing you here are the log income gradients in 3 different samples. So the 2 of them are just the ESS, I think European Social Survey waves with questions comparable to the ones we asked about. I'm also showing you the cross-sectional income gradient in our sample of lottery players. This gradient is calculated with respect to a 10-year average of pre-lottery income. So you can think of it as a gradient with respect to something like permanent income. And then, of course, the problem here is that an annual income is something different from a lottery wealth shock, which represents like a one-time change in your resources. So to try to make these 2 things comparable, what we do is we annuitize the lottery price by just assuming that it's annuitized over a 20-year time horizon at an actuarially fair price. So in other words, we think of the lottery price as a kind of permanent yearly income supplement, and then we compare the effect after it's been rescaled, after it can be reinterpreted as a yearly income supplement, to the log income gradients. That's the basic idea. There are some sort of technical subtleties here that I'm happy to discuss, but I won't go into them unless people are curious. And so what you can see here is that for 2 of our outcomes, our causal estimates are almost bounded away from the gradients. It really depends a little bit on exactly which gradient you want to use. If you just take some sort of sample size weighted average, we can usually reject equality at the 5% level for mental health and for happiness, but obviously not for the middle 2 outcomes. So that's an alternative benchmark for these estimates other than 1. We also did a post hoc analysis where we just split the sample into income tertiles, and then within each tertile compare the causal estimate to the gradient. And of course, the gradient is going to be greater at lower income tertiles than higher ones. And what you see here is that there's a tendency we can typically rule out equality of the causal effects and the income gradients in the bottom income tertile, but not at higher income tertiles. Okay, so how do our estimates compare to previous literature? So I'm just going to show you the answer to that question for one of our primary outcomes, mental health. And as you can see, our estimates are very, very precise compared to previous studies of lottery players that have reported significant improvements in mental health. And these are the 3 that we were able to find after consulting the literature. So in terms of precision, I think our study adds a lot to in terms of reducing the amount of parameter uncertainty. If time permitting, I'll say a little more about that towards the end of the talk. Okay, something quickly about health behaviors. Here are the results. I realize that they're not always so to sort of accommodate everything in a single graph, everything here is in standard deviation units, and I realize that makes it a little bit hard to interpret the cigarette and alcohol coefficients. But overall, what you can see is that it's neither the case that people react to the wealth change by drinking, consuming more alcohol, which is what some hypotheses out there would predict. Nor is it the case, though, that the apparent reduction in improvements in financial circumstances leads to improved health behaviors. The overall pattern that we see in the data is that there's very little change. We can do again the same exercise that we did before by stratifying the sample by along the 5 dimensions that we pre-registered. And again, we don't see a ton of differences, and we can again make the comparison to income gradients. And what we see here is this very clear separation for the subjective and objective health outcomes. So to the extent you think that unearned wealth is similar in its impact to earned wealth, and to the extent that you think our annuitization is like a reasonable way to make these two things comparable, what this suggests is that that the income gradients for these two outcomes, subjective and objective health, are not driven entirely by causal pathways that run from income to health. For the four health outcomes, the patterns are less. The patterns are sort of qualitatively similar, but we have less statistical precision. Okay. So let me say something finally about the sort of precision of our estimates and what they imply in terms of the credibility of previous work. So to do this, I'm just going to illustrate again with one of our outcomes, mental health, and I'm going to use an approach that Gelman and Carling referred to as design calculations. The basic idea here is to use information external to your study about plausible effect sizes to evaluate the credibility of statistically significant findings reported in early literature. So to understand how this works, imagine the following. We can take a previous study that found some statistically significant effect on outcome J, and we can calculate the probability that the study, for a given, assuming we know the true effect size, and I'll have more to say about whether or not that's a realistic assumption, we can calculate the probability that a study with some level of power is going to report an incorrectly signed coefficient, conditional on finding a statistically significant effect. And we can calculate also the type M error, or what Gelman and Carling call exaggeration ratio, which is the expected value of the absolute value of the coefficient, conditional on finding a significant effect, over the absolute value of the true coefficient. Now you can only do this for some true population parameter, right? And so, and generally these two numbers are going to be quite high. I'll have a sort of graphical illustration of this in a moment. Whenever a study has low power, so I'm going to show you this calculation under the assumption that the true effect size is about 4% of the standard deviation. Where do I get this 4% number? Well, it's the upper bound of our 95% confidence interval that we estimated when the outcome was mental health. Okay, and then if you take these previous studies that I showed you earlier, their power to detect an effect size this large was only in the range 5-6%. The probability of reporting the wrong sign, conditional on finding an effect at the 5% level, ranged from 15 to 46%, and the exaggeration ratio ranged from about 6 to 60. So if these previous studies were underpowered, of course an alternative interpretation is just that the effect sizes are larger in these other samples for whatever reason, but at least one of the studies looked at a sample of the Swedish lottery players, and so for that study it's not clear to me that that's a plausible interpretation of the data. But if these previous studies were underpowered, then these calculations suggest their evidentiary value was quite limited. And this is what this looks like graphically. Okay, so the thought experiment is: imagine you do a study where the true effect size is 0.044, and the standard, and then we can calculate the distribution of the test statistic of the study for some standard error, and that standard error we can pull for the data. And here I'm showing you this for the study that had the lowest standard error of the one. So in some sense, I'm stacking the deck against our estimates. Then, well, conditional on finding a significant effect, that means we must have drawn a fairly large value of beta. And as you can see, whenever that happens, well, a good chunk of the time, we're going to have the wrong sign, and the absolute value of the coefficient relative to the truth is going to be very large. I mean, it's going to be it's going. You have to integrate over this red area and this red area to get that average. And that's sort of the danger with underpowered studies. There's a sort of common misunderstanding that if you find something that's significant, that allows you to rule out the null hypothesis at some p-value threshold, then because the test statistic you observe is very unlikely under the null, then this means that the null is probably false. Of course, in order to make that statement, before you can make such statements about credibility, you also need to know what was the likelihood of this happening under the alternative hypothesis. And if under the alternative hypothesis the study had very low power, then it's also unlikely under the alternative hypothesis. Okay, so to conclude, we've investigated these medium to long-run effects of unearned wealth on psychological well-being and on health behaviors. We find causal effects that are larger than household income gradients at very low incomes and similar in magnitude to gradients at higher income levels. Overall, we can reject the household income gradients for happiness, for mental health, and for our measures of subjective of objective health and some of our health behaviors. Overall, what we find is that these large wealth shocks appear to induce permanent but modestly sized reductions in financial stress. And to the extent that these reductions in financial stress and other benefits have downstream consequences on health behaviors, and psychological well-being, those downstream consequences appear to be too small to be detectable in our sample. So that concludes my talk, and I'm happy to take questions or continue the conversation.